Good morning, students. So in this class we solve problems on formation of partial differential equations by eliminating arbitrary constants. So here the first problem: form the partial differential equation by eliminating the arbitrary constants from the equation x minus a whole square plus y minus b whole square plus z square equal to 4 plus z square equal to 4. So this is the given expression, and we form a partial differential equation by eliminating arbitrary constant from this expression. Okay, so first write the given equation: x minus a whole square plus y minus b whole square plus z square equal to 4. Now call this equation as 1. Call this equation as 1. So now in this, what we do, we eliminate constant, arbitrary constants a and b. So to eliminate, what we do, we differentiate this equation 1 partially with respect to x. So differentiating equation 1 partially with respect to x. So what we obtain? So while differentiating with respect to x, y is treated as constant. So differentiation of x minus a whole square, 2 into x minus a, then plus this is 0, and then here we have to differentiate this 2z into dou z by dou x, because z is a function of both x and y. So therefore dou z by dou x is equal to, this is constant, 0. Or this can be written as 2 into x minus a is equal to, now send this term to that side, so minus 2z dou z by dou x. So now both the sides 2 will get cancelled, right? This 2 and 2 will get cancelled, which gives x minus a is equal to minus z into dou z by dou x. Okay, so now similarly differentiating 1, partially with respect to y, So what we obtain? So while differentiating with respect to y, x is treated as constant. So differentiation of this first term becomes 0, plus second term 2 into differentiation of y minus b whole square is 2y into y minus b, then plus here 2 into z into dou z by dou y, which is equal to 0. Or this can be written as 2 into y minus b is equal to, send this term to that side, minus 2z dou z by dou y. Again here 2 get cancelled, which gives y minus b is equal to minus z into dou z by dou y. Okay, so now we have differentiated partially with respect to x and y. Next we have to eliminate the arbitrary constants. So we have to eliminate the arbitrary constant. So eliminating the arbitrary constant means what? So here we have differentiated and we got some derivatives. Now what we do, we find the value of a and b in terms of derivatives. We find the values of a and b in terms of derivatives, and then substitute those values of a and b in the given equation 1. This is one technique. And another technique, if you want to eliminate a and b, okay, eliminate it, or otherwise you can eliminate the term containing the constant, that also you can do. So here this is a term which contains a, and this is another term which contains b. Now in the given equation we have x minus a and y minus b. Suppose that if you differentiate partially with respect to x, differentiate partially with respect to y, suppose from those two differentiation, if you obtain the value of x minus a and y minus b, then substitute those values of x minus a and y minus b in this equation 1. So that gives the required partial differential equation. So now see here, I have differentiated partially with respect to x and I obtain the value of x minus a, and this x minus a, it is in the given equation. Okay, so I substitute x minus a as minus z into dou z by dou x in this equation. Similarly, I have differentiated partially with respect to y and I got the value of y minus b, which is minus z into dou z by dou y. So now what I do, I substitute this value of y minus b in this equation. That's all. So call this equation as 2 and this is a 3. Now substituting x minus a and y minus b from 2 and 3. From this 2 and 3 we take x minus a and y minus b and we substitute that in the equation 1. In equation 1, then we get, so x minus a means minus z dou z by dou x, x minus a whole square means square. Then similarly y minus b whole square, so y minus b means minus z dou z by dou y whole square equal to 4. A plus z square equal to 4. Okay, or in other words, this is after squaring this becomes z square into dou z by dou x whole square. This is z square into dou z by dou y whole square plus z square equal to 4. So now this implies, now already I told in the last class, that is dou z by dou x means it is p, dou z by dou y means it is q. So replace that, this gives z square into, this is p square, z square into this is q square plus z square equal to 4. So this is the required partial differential equation, which is obtained by eliminating arbitrary constants. So here you can write where p is dou z by dou x and q is dou z by dou y. Q means dou z by dou y. Okay, so this is how we solve the form a partial differential equation by eliminating arbitrary constant. Similarly, we can solve another problem. We solve another problem, that is form PDE by eliminating arbitrary constants from the term z is equal to ax plus by plus c. Okay, so which is a very simple equations. So here again we write the given equation, z is equal to ax plus by plus c. Now call this equation as 1. Again apply the same technique, differentiating 1. Creating equation 1 partially with respect to x. So we obtain this is dou z by dou x equal to a, differentiation of x with respect to x is 1, and plus here while differentiating with respect to x, y is treated as constant, this is 0 and this is 0. Okay, so which implies a is equal to dou z by dou x. Similarly, differentiating equation 1 partially partially with respect to y. So then we get dou z by dou y is equal to, so while differentiating with respect to y, x is treated as constant, so that means this first term becomes 0, then differentiation of b y is b into differentiation of y with respect to y is 1, then plus c is constant, its differentiation is 0. So this implies b value is dou z by dou y. So this is equation 2 and this is equation 3. Now we got the values of a and b in terms of dou z by dou x and dou z by dou y. So now substituting a and b from equation 2 and 3 in y, from equation 2 and 3 in this equation 1. Okay, so then we get z is equal to, a means dou z by dou x into x, plus b means dou z by dou y into y, plus c into y plus c. Okay, so now actually what is dou z by dou x and dou z by dou y? Now since dou z by dou x is equal to p and dou z by dou y is equal to q. Now substitute these values here. This implies z is equal to px plus qy plus c. So which is the required partial differential equation obtained by eliminating arbitrary constants from the given expression, that is z is equal to ax plus by plus c. Okay, so that's all for today's session, and we will continue in the next classes with new problems. Thank you.